the NDCG metric to evaluate recommender systems. NDCG stands for Normalized Discounted Cumulative Gain. So let's see what this means. You'd have heard of the popular MAP at K metric that's used for recommender systems. And the MAP metric is useful when you have a recommender system where the user gives feedback whether an item is relevant or not. But there are explicit feedback recommender systems where the user actually can give you a specific rating for each of the items recommended. So Netflix used to do this at some point, for instance, where it would give you a bunch of movies and asks you to recommend the rating for each of the movies, right? So when the user gives explicit feedback, you can actually do a little more than just look at whether an item is relevant or not. So one of the simplest metrics you can do is a regression metric, like let's say RMSE or the root mean square error, which is seeing how different is the relevance given by the user different from the relevance that you predicted based on which you showed the items. But the problem is simple metrics like RMSE do not take into account the ordering of the items. So the NDCG metric is something that considers the ordering of the items. So let's look at what normalized discounted cumulative gain means. Gain here is nothing but the relevance score. Cumulative gain is nothing but the sum of relevance scores of all the items shown. So let's say you have recommended K items. You have shown the top 3 items. Then this is just the sum of the relevance scores or the gains of the 3 items. But the challenge with this is again that it is not really showing the order, giving importance to the ordering of the items. So you want the most relevant items to appear at the top, and if that happens, you want a higher score. How do we do that? So the discounted cumulative gain is computed by dividing each term in the cumulative gain by something that contains the position of that term. So I is the position in the order in which these results were shown. So if an item is shown at the top, I is 1, then you would get 1 in the denominator, so log 2 to the base 2. But if you have, like, let's say the 10th item, then you will have log 11 to base 2 in the denominator. And this would be, giving more weightage to the top terms compared to the bottom terms. That's the whole idea. One challenge with the DCG metric, which can in itself be used in a lot of applications really, but one of the challenges is that you cannot compare across 2 different recommenders that are recommending different number of items. For instance, I have one recommender that's recommending 5 items and another recommender that's recommending 10 items for the same problem. Now, the first one will always usually have a smaller score than the second one, which has more terms, and because of which it will just end up with a larger score, and it's really hard to compare which one is doing better. So the normalized discounted cumulative gain is same as the discounted cumulative gain, but it is normalized so that you can compare apples with apples when you look at 2 different recommenders. So what is the denominator in the NDCG metric? So the numerator is the same as discounted cumulative gain that we saw. The denominator is the discounted cumulative gain in the ideal scenario, which means, so based on the relevant scores given by the users, if we actually re-rank the items that are shown, what is the discounted cumulative gain? So let's take an example to understand this. Suppose we have shown 3 recommendations. We showed document 10, document 3 and document 1. And the user has given relevant scores as 3, 4 and 3 for these documents. Now, if we reorder and put them in the relevance order given by the user, 4, 3 and 3, we get document 3, document 10 and document 1. So the discounted cumulative gain can be computed from this, while the ideal discounted cumulative gain is computed from this particular ranking order. So let's see, discounted cumulative gain is computed by taking each of these relevant scores and dividing by the log to base 2 of the position plus 1. So 3 by log 1 plus 1, 4 by log 2 plus 1, and again 3 by log 3 plus 1. The ideal discounted cumulative gain is given by 4 divided by log 1 plus 1 plus 3 divided by log 2 plus 1 and 3 divided by log 3 plus 1. So we note that the IDCG will always be slightly greater than the DCG because this is the highest, most relevant document will be at the top in the ideal ranking. So uh, NDCG, which is the ratio of the discounted cumulative gain and the normalization factor, will be always less than 1. Right, in this case we got 0.94, which is not very bad. To recapitulate, we looked at the normalized discounted cumulative gain metric to evaluate recommender systems where we get explicit feedback or a relevant score from the user, and it is something that helps us see how relevant a particular item is, and also gives importance to the fact that the topmost items are most relevant. Thank you.